Chapter 8, Rational Functions. Okay, I made these notes. I'll post these on Google Classroom. All right, so a rational function is a function that can be written as one polynomial divided by another. So, for example, f of x equals p of x divided by q of x. All right, as always, to find the y-intercept, you set x equal to 0. And to find the x-intercept, you set the numerator equal to 0. So we'll get to a few examples in a moment. So the definition, or at least my definition of an asymptote, it is a dashed line on a graph that the function approaches but never reaches. So let's take a look. So right here we have the graph of f of x equals 1 over x minus 1. Okay, and we know that a denominator cannot equal 0. So if you set the denominator equal to 0, x minus 1 equals 0, and you do plus 1 on both sides, you get x equals 1. So that right there is a vertical asymptote, which we'll get to on the examples. But if you go to x equals 1, this is the x-axis here. If you go to x equals 1, and you draw a dashed line, and this dashed line here is basically x equals 1, you will see that the graph approaches x equals 1, but it never reaches it. So approaching it from the right-hand side, it goes up. Approaching it from the left-hand side, it goes down. Okay? And how would you come to that conclusion? Well, basically, you plug in a point that is close to x equals 1, but doesn't reaches it, never reaches it. For instance, if you plug in, I'll do it in a different color here. If you plug in, say, x equals something close to 1 from the positive side, like 1.001, what you get is a y value that approaches infinity. Okay? And if you keep doing points that are closer and closer to 1, like you can do 1.0001 and so on, the y value will just keep increasing. Okay? And same thing if you do that from the left-hand side. Let's say you choose a number that's close to 1 but less than 1. Let's say you plug in x equals 0.999. And what happens to the y value? Well, the y value just approaches negative infinity. So that's how you know the direction that the graph is headed as it approaches the asymptote. Okay, we'll get into that later. Anyhow, like we just said, to find the vertical asymptotes, you set the denominator equal to 0 and solve for x. So that's basically what we just did on the example. And now for the horizontal asymptotes, there are 3 possibilities. In the first case, the degree of the numerator is greater than the degree of the denominator. Let me fix this here. All right, for the horizontal asymptotes, the degree of the numerator is greater than the degree of the denominator. That's basically the exponent on the variable. And in that case, there is no horizontal asymptote. If the degree of the denominator is greater than the degree of the numerator, the horizontal asymptote is at y equals 0. That's the x-axis. And finally, if the degree of the numerator equals the degree of the denominator, the horizontal asymptote is at y equals a sub n divided by b sub m. What does that mean? Well, a sub n is going to be the leading coefficient of the numerator. B sub m is the leading coefficient of the denominator. Okay, so you just take the 2 leading coefficients and you make a fraction, and that will be your horizontal asymptote. So you will see at least one of each case in the examples we're about to do. All right, first example, find the intercepts, vertical asymptotes, and horizontal asymptotes. All right, for the intercepts, we've done that before. Let's do the y-intercept first. All right, for the y-intercept, basically what you do is just set x equal to 0. Okay, pretty simple. So in our function, we just plug in a 0 wherever you see an x, so that's going to be 0 squared minus 16. And that's divided by 3 times 0 plus 1. All right, and of course the terms with 0, 0 squared is 0, 3 times 0 is 0. Those just drop out. Negative 16 divided by positive 1 is just negative 16. All right, pretty simple. And for the x-intercept, we said in the notes that you set the numerator equal to 0. All right, and that makes sense because if the numerator is 0 and it's 0 over something other than 0, then the whole thing is 0. All right, so I'm going to let x squared minus 16 equals 0. All right, and let's see, plus 16 on both sides, so that's going to be x squared equals 16. All right, and taking the square root on both sides, x is going to equal plus or minus 4. All right, square root of 16 is 4. But when you do it on both sides, it's going to be plus or minus 4. All right, basically by setting the numerator equal to 0, we're basically setting y equal to 0. All right, remember this is like y equals right here. If it's f of x, this is y equals. The numerator would make it 0. So the x-intercept is at plus or minus 4. The y-intercept is at negative 16. You can write y equals negative 16 if you want, but it's not the line. It's just a point, really, for the intercept. All right, next up, vertical asymptotes. We said in the notes for the vertical asymptote, you set the denominator equal to 0. Okay, so let's see. I'm just going to write VA for vertical asymptote, and I'll write in parentheses, denominator equals 0. All right, so that's going to be 3x plus 1 equals 0. And if I do minus 1 on both sides, I'm going to have 3x equals negative 1. And the opposite of times 3 is divided by 3. Solving for x, the 3's cancel. And x equals negative 1/3. All right, so that's your vertical asymptote. Finally, the horizontal asymptotes. Let's see. Right here, if you look, the degree of the numerator is a 2. The degree on the denominator, this is just x to the 1. So the numerator degree is greater than the denominator degree. All right, so for the horizontal asymptote, let me see if I can make room here. All right, horizontal asymptote, in this case, the degree of the numerator is greater than the degree of the denominator. All right, so let's take a look at the notes. When the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. So the answer here for the horizontal asymptote is just none. Example 2, here we have g of x equals 15 divided by x squared minus 4x minus 5. Okay, once again, for the y-intercept, you set x equal to 0. All right, so we have 15 divided by 0 squared minus 4 times 0 minus 5. All right, anything times 0 is just 0, so that's gone and that's gone. 15 divided by negative 5 is just negative 3. All right, so that's your y-intercept. And the x-intercept. What did we say for the x-intercept? The numerator equals 0. Now, on this function here, can the numerator ever equal 0? No. If you set 15 equal to 0, that'll never happen. So as far as the x-intercepts, there are none. All right, because 15 can't equal 0. All right, now for the vertical asymptote. Basically, for the vertical asymptote, we set the denominator equal to 0. All right, so this here is the denominator, x squared minus 4x minus 5. And we set that equal to 0. We set the whole denominator equal to 0. How do we solve this? Factoring or quadratic formula? Well, do we have two numbers that multiply to negative 5 and add to negative 4? Yes, indeed we do. Okay, so we can have two binomials here. And for negative 5, we can use negative 5 and positive 1, right? Negative 5 times 1 is negative 5. Negative 5 plus 1 is negative 4, so that works. X minus 5 and x plus 1 equals 0. Okay, if you do x minus 5 equals 0, then x is going to equal 5. And if you do x plus 1 equals 0, x is going to be negative 1. Remember, anything times 0 equals 0. So this one can be 0 and this one can be 0. All right, so those are your vertical asymptotes. And finally, what is the degree of the numerator? Since there's no x there, it's basically the equivalent of x to the 0, because x to the 0 is just 1, and 15 times 1 is just 15. So x to the 0, the degree here is just 0, and the degree in the denominator is 2. So which one is greater? Well, clearly the degree of the denominator is greater than the degree of the numerator. All right, so for the horizontal asymptote, we said the degree of the denominator is greater than the degree of the numerator. All right, denominator degree is greater than numerator degree. So what happens in that case? Let's look at the notes. When the degree of the denominator is greater than the degree of the numerator, the horizontal asymptote is at y equals 0, basically the x-axis. All right, so in this case here, y equals 0 is the horizontal asymptote. And just for fun, you don't have to write this on your homework, but why do you think that is? Why is it y equals 0? Well, if you look at the function, what happens if x approaches infinity? As x goes to infinity, the x squared gets bigger and bigger, larger and larger. The denominator itself, the whole thing gets larger and larger because x squared is going to outpace negative 4x because it has an bigger exponent on it. As the denominator gets bigger and bigger, you're going to have 15 over a really large number. As x goes to infinity, it's going to be something like 15 divided by infinity. All right, so as the denominator approaches infinity, the whole thing approaches 0. So g of x is basically y equals. And what happens as x approaches infinity? Well, y approaches 0. Okay, because the denominator just keeps getting bigger and bigger. So that is why when the degree of the denominator is greater than the degree of the numerator, that's because it'll increase much faster. And when this increases faster, it makes the whole function go to 0. All right, example 3. Let's find the y-intercepts first. All right, we said x equal to 0. So that's going to be 3 times 0 squared divided by 0 squared plus 2. Anything times 0 is going to be 0. And 0 squared is 0. We have 0 divided by 2, and that's just 0. That's your y-intercept. For the x-intercept, we set the numerator equal to 0. All right, 3x squared equals 0. And here we have x times 3. The opposite of times 3 is divided by 3. The 3's cancel. And 0 over 3 is just 0. So if x squared equals 0, then x is also 0. Again, this is for the intercept. So this is not the line x equals 0. Really, I shouldn't really write it like that. The x-intercept is just 0. All right, you go to the x-axis, and that's at the point 0 where it crosses the x-axis. All right, vertical asymptote. We set the denominator equal to 0. So how do we do that here? We have x squared plus 2 as a denominator, x squared plus 2 equals 0. If I do minus 2 on both sides, x squared is negative 2. Can x squared ever equal negative 2 without imaginary numbers? No, it cannot. Okay, you can't have an asymptote with imaginary numbers. So right here, we actually have none. No vertical asymptote. Finally, the horizontal asymptote, the HA. What do we have here? The degree of the numerator is what? 2. The degree of the denominator is what? 2. So basically, for the horizontal asymptote, the degree of the numerator equals the degree of the denominator. Let's take a look at the notes. All right, in the case when they are equal, the horizontal asymptote is a sub n over b sub m. So you take the leading coefficient of the numerator and put it over the leading coefficient of the denominator. So let's take a look at that. All right, for leading coefficient, you go to the highest exponent. There's only one exponent here, and the coefficient on the x is a 3. And on the bottom, the highest exponent, it's x squared. There's no other x's. And the coefficient on the x squared is 1. Okay, so if you took this leading coefficient, that's a 3. And you take this leading coefficient, that's a 1. It's just going to be 3 over 1. All right, so the horizontal asymptote is 3 over 1, or just 3. Okay, remember horizontal asymptote is going to be like that. It's horizontal. It's going to be y equals some number. So in this case, it's basically y equals 3. And again, you don't have to write this on the homework, but let's discuss why WHY. Why did this occur? Well, let's look at the function itself and see what happens. Well, let's see. If x approaches infinity, basically what happens here? In the numerator, you're basically going to get 3 times infinity. And in the denominator, you're just going to get infinity plus 2. All right, so it's going to be 3 times infinity over infinity plus 2. All right, infinity plus 2 is basically the same as infinity. I'll show you in another way. This is like informal here, but these will cancel and you'll just get a 3. I'll show you a different way, though, that you know it approaches 3. All right, if you take this function, and I want to get rid of the x squared, I'm going to multiply the top by 1 over x squared, and I'm going to multiply the bottom by 1 over x squared. Okay, I am multiplying by the same thing divided by itself. So in the numerator, we have 3x squared times 1 over x squared. And in the denominator, we have x squared plus 2 times 1 over x squared. All right, and what happens? X squared divided by x squared, we're multiplying fractions here. X squared divided by x squared cancels, and in the numerator, 3 times 1 is just 3. And the denominator, x squared divided by x squared cancels, so that's just 1. And 2 times 1 over x squared is going to be positive 2 divided by x squared. So this function here is the same as the original, it's just in a different form. And now if you look at this function here, what happens when x goes to infinity? As x gets larger and larger, what happens here? You get 2 over a big number. This thing just approaches 0. The 2 over x squared, it just approaches 0. And you're left with 3 over 1. So as x approaches infinity, y approaches 3. All right, so that's why for the horizontal asymptote, when the degree of the numerator and denominator are equal, you just take the leading coefficients and divide them. Okay, and you'll get this right here. You don't have to do this on the homework problems. I am just showing you why this works. Okay, so when the exponents are equal, you just take the coefficients, leading coefficients, and divide them, and you will get your horizontal asymptote. All right, just a couple more examples where we're going to find the horizontal asymptotes. Now, you don't have to do it the way I'm going to do it. This is just to prove to you why the notes work. All right, so what I'm going to do, I see the highest exponent, x to the 4th. I am going to multiply the top or numerator by 1 over x to the 4th. And I'm going to multiply the bottom or denominator by 1 over x to the 4th. Okay, the same term over itself, it's basically the same as multiplying by 1. All right, so I'm allowed to do that. Now, in each case here, when we multiply or distribute 1 over x to the 4th, each of these terms is going to be divided by x to the 4th. So 3x to the third divided by x to the fourth, that's going to be 3 over x. Positive 5x squared divided by x to the fourth, that's going to be 5 over x squared. Positive x divided by x to the fourth, that's 1 over x to the third. And negative 6 divided by x to the fourth is as is. In the denominator, 2x to the fourth divided by x to the fourth, that's 2. Positive 8x squared divided by x to the fourth is going to be positive 8 over x squared. And negative 1 divided by x to the fourth, that is as is. And now, the way the equation, or the way the function is set up, we can see what happens as x approaches infinity. All right, if you take this function here, what is going to happen when x goes to infinity? In other words, x just gets larger and larger. Well, right here, if the denominator goes to infinity, gets larger and larger, this is going to go to 0. And same thing here, x squared, larger and larger. Denominator, this is going to be 0. Same thing here, this is going to be 0. Same thing here, this is going to be 0. All right, on the bottom, we just have to make sure it's not 0. This is 2. This one, large denominator, is going to go to 0. This large denominator, the fraction goes to 0. So we have all zeros divided by 2. And of course, if you do 0 divided by 2, that just equals 0. Okay, so this function was basically f of x, or y equals. So it becomes y equals 0. All right, and that right there is your horizontal asymptote. All right. Now, again, you do not have to do the problems this way, the practice problems. This is just me showing you why the notes work. So let's consult the notes and confirm that the horizontal asymptote is y equals 0. What we have here is the degree of the denominator, which is 4, is greater than the degree of the numerator, which is 3. So let's check the notes. All right, these were the 3 cases for horizontal asymptotes. Number 2, the degree of the denominator is greater than the degree of the numerator. The horizontal asymptote is at y equals 0. So this right here is exactly what we got. All right, so that's why it is y equals 0. Another simpler way to look at it, if the degree of the denominator is greater, that means when you plug in larger and larger values of x, the denominator is going to increase faster because it's to the 4th power rather than to the 3rd power. And if the denominator gets really big, much faster than the numerator, the fraction gets smaller and smaller, and the whole thing is going to approach 0. So that's another way to look at it. All right, last one. I can see the greatest exponent is a 3, x to the third. So I'm going to take this, and I'm going to multiply the top, or numerator, by 1 over x to the third, and the bottom, or denominator, by 1 over x to the third. Okay, so I'm just doing times 1 here. All right, each time you distribute this term, it's going to be divided by x to the third. So 4x to the third divided by x to the third is just 4. 8x squared divided by 8x to the third is 8 over x. Negative 5x divided by x to the third is negative 5 over x squared. Plus 3 divided by x to the third. On the bottom, 9x to the third divided by x to the third is 9. x squared, negative x squared divided by x to the third is negative 1 over x. Positive 8x divided by x to the third is positive 8 over x squared. Plus 3 over x to the, minus 2 over x to the third is as is, negative 2 over x to the third. Okay, and now what happens as x goes to infinity? As x approaches infinity, as x gets larger and larger, the denominator gets large, the numerator stays as is, the fraction goes to 0. Denominator gets large, fraction goes to 0. Same here. Same here. X goes to infinity, fraction goes to 0. X to infinity, fraction to 0. And what are we left with? 4 in the numerator, 9 in the denominator. So that's going to be y equals 4 over 9. And that right there is your horizontal asymptote. Okay? As x goes to infinity, the graph, the y part of the graph, approaches 4/9, but it never reaches 4/9. Okay? That's why it's a horizontal asymptote. So once again, you don't have to do the problems like this. I'm just showing you. All right? Let's go to the notes and see if we get 4/9 without doing this stuff. Okay, in the notes, when the degrees of the numerator and denominator are equal, you just take the coefficients, the leading coefficients of the numerator and denominator, you make a fraction, one over the other. Okay, you just look at the leading coefficients. So back to the problem. The leading coefficient here, the greatest exponent is 3. The coefficient is 4. The leading coefficient, greatest exponent is 3. The coefficient is 9. So it's just 4 over 9. You just take the coefficients when the leading exponents match. 4 over 9. And is that what we got? Yes, it is. Okay, so I was just showing you how it approaches 4 over 9 and why this works.